Hello, here we are with section 5.4, inverse functions. It's an important idea for more advanced kinds of math. And to really understand it, I think it helps to do some exercises yourself to see how inverse functions work. So that's why we're starting off with some exercises here. These are function composition examples. So hopefully you've already at least watched the 5.2 the 5.2 video and maybe started the homework and gotten some practice with that. So if you haven't done these exercises now, let's pause it here and do these and then check them in a minute. Okay, and we're back. So if with this one, if we're going to find f of g of x, I think I'm going to write f of x in blue and g of x in green here. So f of g of x is going to be f of x minus 7. So we're replacing the x here with x minus 7. So in the formula for f. So this means we're going to do x minus 7 plus 7. And you can see these functions undo each other. X minus 7 plus 7, it cancels out, and you just end up with x. Okay, now what if you do this the other way around? G of f of x. This is going to be g of, well, f of x is x plus 7. Like so. And what does that work out to be? Well, what does g do? We're going to take its input, which is x plus 7, and we're replacing x with that. So that's going to look like x plus 7 minus 7, and that works out to just be x. So those are the answers to that. Both of these functions, either way you compose them, they sort of cancel each other out and just give x. All right, let's see that happen with the rest of these. So here, if we do f of g of x here, this is going to work out to be f of x over 3. And what does f do with its input? It multiplies it by 3. So we're going to do 3 times x over 3, and that just gives you x. Okay, and how about if we do g of f of x? That should be g of 3x, because the f of x here is this 3x part. And what does g do with its input? It takes the input and divides it by 3. So this is going to be 3x over 3, and that cancels out and just gives you x. Okay, so a similar thing happens. 3 times x and x divided by 3 are opposites in the sense they cancel each other out. Let's check this with the rest of these. Here, if you do f of g of x, this is going to be f of negative x, which is going to, so I'm replacing the g of x with its formula, negative x, and then f of its input says you make it negative. So this is going to be negative, the opposite of negative x, which is the opposite of negative x is just x. And then here, if you do g of f of x, doing it the other way, this is going to give you g of negative x, which is the opposite of negative x, which is just x. Alright, so it happened there again. These functions cancel each other out. Except in this case, they were actually the same function. Here's another situation where they are the same function. Let's see if these ones cancel each other out. If we do f of g of x, the g of x is 1 over x, so I'm going to rewrite this as f of 1 over x. And that 1 over x is now the input into f now. So what does f do? It does 1 over that. Okay, so fractions within fractions are no fun. I like to deal with this by multiplying both sides by x, because the x times 1 over x cancels out, and you end up just getting x over 1, which is just x. So that works. And you can see it's going to work out exactly the same way when you do it the other way around. And there's that answer. Alright, now what if they're a little bit more complicated here? Let's see what happens. Are these ones going to cancel out in the same way? We're doing f of g of x first here. The g of x I'm going to replace with x plus 5 over 3, which is the formula for that. And then we're going to see what does f do with its input. It takes the input, multiplies it by 3, and subtracts 5. So that's going to be 3 times this x plus 5 over 3 minus 5. Alright, and here the 3's are going to cancel out. 3 times something divided by 3 just cancels out. So you end up with just x plus 5 minus 5. That cancels out to just give you x. So that's that. Now what about the other way around? G of f of x. So this is the same thing as g of, well, the f of x is 3x minus 5. And g of that, well, let's see, it takes the input, adds 5, and divides by 3. So we're going to do that with 3x minus 5. We're going to add 5 and divide by 3. So the minus 5 plus 5 cancels out, and you just end up with 3x over 3, and that reduces to just be x. So yeah, these two cancel out the same way. Let's see if these ones do as well. So the g of x is the cube root of x plus 1. And f is going to take that and do minus 1 and then cube the result. So I take the cube root of x plus 1, and then f says minus 1 and then cube it. So the plus 1 minus 1 comes out, cancels out, and we'll just get the cube root of x cubed. Which of course just cancels out and leaves you with just that x. And if we do it the other way around, we'll get, let's see, f of x is x minus 1 quantity cubed. We're going to plug that result into g, which says take the cube root of that and then add 1. And so here, the cube root cancels out with cubing it. We just end up with x minus 1 plus 1, which of course cancels out to just give you x. Okay, so yeah, here you can see each of these pairs of functions have this special property that when you do the composition with them with each other, they sort of cancel each other out and just leave you with the original input. Now let's look at exercise 2 here. Solve 4x in terms of y. So again, that means that the goal is to get something that looks like x equals some kind of formula with y in it somehow. But we don't know what that formula is exactly. So we want to get x by itself on this side, so I'm going to add 5 to both sides. Oh, by the way, if you didn't notice yet, this y equals 3x plus minus 5 is the same as this f of x here. So just it's worth noticing that that's true. All right, so we got y plus 5 equals 3x. Divide everything by 3, and oh hey, lo and behold, you get y plus 5 over 3 is equal to x. So isn't that interesting that solving 4x in terms of y, let's look at this function here. This function is the same as the function that cancels out the original, this is the same as the g of x. This is the function g of x that cancels out this original function f of x here. And we got that function by solving for x in terms of y. Pretty cool. Okay, let's do the same thing here. We want to cancel out this cube root, cancel out the cube, the exponent 3. So we're going to do a cube root to both sides. And that just leaves you with the cube root of y equals x minus 1, and then you can add 1 to both sides, and you'll get the cube root of y plus 1 equals x. And lo and behold, the same weird thing happened. This y here is the same as this g of x function here. And going through the steps to get the x by itself in terms of y, like what do you do to y to get x, that's the same thing that would undo this function. If you were going to compose this function, like take this thing for y here and plug it into this y, they would undo each other and you would just end up with x equals x. Okay, so up next we're going to see that this has a name. These kinds of functions are all called inverses of each other. I'll explain that and then do a couple examples of some stuff that happens. So a weird example where some unpleasant stuff happens, and then a real life example where you can see why inverse functions might be useful for describing stuff in real life. And that will be in the next video, and I'll talk to you then.